Any questions from the homework? Since we are not going to have a quiz today, so I'm going to have a time to answer your questions. Do you have any questions? Nope. All right, so we're going to study some new ideas to evaluate the integrals, and that's called trigonometric substitutions. Those are the useful substitutions for certain problems. I'm going to do some exercise in class. Just substitution. We're going to learn some substitution. Now, when you see radicals in the integral, you will see that, okay, this will be a difficult problem. So it's very hard to, it's not a polynomial, right? It's harder to find the antiderivative of those functions. So the first thing you have to do is trying to get rid of the radicals. In order to do that, we use trigonometric substitution, because we have those formulas. We have 3 formulas we can use it. For example, 1 minus sine square theta, right? It becomes cosine square theta. So the radical, okay, the radical is going to be like 1 minus sine square theta equals this. Now you can get rid of radical using this. It's going to be cosine theta if the theta is between pi over 2, okay? Because cosine theta is positive. So this is the first important formula. A second important formula is going to be, this is a can be lesson. Second important formula is going to be 1 plus tangent square theta, okay? That becomes secant square theta. So if you have the radical, right, then you can get rid of the radical, but that's still true for pi over 2. Right? So this is the second formula. You know, if you see square root of 1 plus something square, and if you use a substitution, and you can get square, secant square, then radical square root secant square will be just secant. Okay. So the third one is going to be 1 minus look at this above identity, right? I can also move 1 to the right hand side to get tangent square theta, right? So it's the same identity. This is the same identity, okay? And then the radical, we get tangent theta. So those are the useful formula, and but be careful when you for this one, the theta will be different, because eventually we are going to use the inverse function. So remember, for the secant theta, the inverse function, the theta should be, the range is going to be between 0 and pi over 2, or between pi and 3 pi over 2. Okay, and over this intervals, tangent theta is still positive. Okay. Yeah. So this is the why we have to restrict theta to those 2 intervals, because I'm going to find the this is where we define the inverse, because when you use x equals secant theta, you have to solve for theta. Then theta must be one of those two integrals. Okay, this is about inverse function, coming from the inverse function domain. All right, so let's take a look at the following problem. And the first problem I want to discuss is just yeah. Let's look at the following. So remember, right? If you want to find the area of the semicircle or the circle, the whole circle, right? With radius r. How do you find the area? Right? How do you find the area? The area, if you find the area of the semicircle, you can find the area of the circle. So the area is going to be double the integral. It's from negative r to positive r. And the function on the top is y equals r squared minus x squared, right? The function at the bottom is this. So it's defined, yeah, it's going to be r squared minus x squared dx. Now you say, okay, have a radicals. How can I evaluate this integral, right? It's not easy. You can try by integration by parts, but that does not work. Okay, it's not easy to do that. Okay, integration by part. So there any other method we learned, right? No, integration by part, it's not working. So use substitution. If you use substitution, the nature of substitution is r squared minus x squared equals u squared. But then still, I don't think it works. Okay, so the possible substitution is x equals r sine theta. Right? Anyway, x is between negative and positive r. So theta is between negative pi over 2 and positive pi over 2. So now you have this substitution you left, right? So for this substitution, when x equals negative r, if theta equals negative pi over 2, right? X equals positive r equals theta equals positive pi over 2. So this is the correspondence. Okay. I also needed to know, yeah, r squared minus x squared is going to be r squared minus r squared sine squared theta. You see? So you will get 1 minus sine squared theta. 1 minus sine squared theta is cosine squared theta. It's going to be r cosine theta. So you get rid of the radical. That's good. But be careful, the integral involves dx and the function. So what is dx? Dx is going to be r cosine theta d theta. Okay, not too bad. Okay. So we did all the computations. So the area is going to be twice. And I needed to change the interval for the integral. Okay, it's going to be negative pi over 2 to the positive pi over 2, and here's r cosine theta and r cosine theta d theta. Not too bad. So using advanced mathematics calculus, right? And you can get a formula we used in the middle school, area formula. Okay, we cannot prove the area formula in the middle school. Okay. So this is r squared. The integral cosine square theta. So that's going to be 2r squared. How can I evaluate cosine square theta? That's from last class, right? You cannot do that unless you modify it. Cosine square is going to be cosine square, right? It's, cosine, I always forget this. Cosine 2 square is 2 cosine square theta minus 1. So in order to get the cosine square, that's cosine 2 theta plus 1 divided by 2. Right. Then you find the antiderivative of this function. Okay, the antiderivative of this function is going to be 1/2. The antiderivative of sine 2 theta is cosine 2 theta sine 2 theta divided by 2, and plus 1/2 theta. So that matrix happens, we're going to get to the area of the circle with radius r. Sine 2 theta, the difference at the two endpoints is going to be 0, because sine 2 times pi over 2 is sine pi, which is 0. Sine 2 times negative pi over 2 is sine negative pi. It's also 0. So don't worry about that. So what you get is pi over 2 minus negative pi over 2. And that is a pi. So it's going to be just pi r squared. Okay. So that is the area of the circle. Now we can prove that using advanced mathematics. That's the reason you have to study more advanced mathematics in order to get some formulas for mathematics at the lower level. Okay. So you're wondering, is there any high level mathematics above? We are undergraduate, right? All right. If you take a math courses, course number is below 500. They are all undergraduate level mathematics. So above that, there are another 4-year mathematics before you get a PhD degree. So the number is all the way to, I think, a 698, something like that. Math 698. Yeah. For me, I graduate after I get my bachelor degree. I stay in the school for 7 more years. 3 years for master degree and 4 years for PhD degree. I shouldn't shorten the time, but I did not do that. Okay, I still understand only a small section of the mathematics. All right, so the next problem is evaluate the integral. It's 1 minus x squared over x in dx. Right, so this is a it's more complicated function. Compare the previous one, you have x squared in the denominator, right? So then how do you simplify it? How do you evaluate? We do have we learned right, we learned this integration by parts or some other substitutions. None of them it works. So when I see 1 minus x squared, maybe I can get rid of the radical. In order to get rid of radical, you have to set x to be sine theta, right? That's clear. So try this first. So more exercise you do, more experience you're going to get. Okay. So dx, then dx equals cosine theta and d theta. Okay. Okay, so don't forget, this is very important, dx in the integral, okay? So then the integral becomes square root, 1 minus x squared is going to be sine square theta, right? So the integral as a square root will be sine theta, okay? It's cosine square theta. Because it's 1 minus sine square theta, so that's going to be cosine theta, okay? Square root 1 minus sine square theta, cosine theta. But that's theta. Anyway, x is between negative and positive 1. So that theta is always between negative pi over 2 and positive pi over 2, okay? So this is substitute. When x runs from negative pi over 2 to positive pi over 2, x, when theta runs from negative pi over 2 to positive pi over 2, x runs from negative 1 to positive 1. Right? So it's going to be cosine theta, okay? And denominator is a sine square theta. Okay, that's good. What is dx? Dx is cosine theta d theta. Okay. So now what? You have sine square, cosine square theta, sine square theta, d theta. This is a cotangent. This is a cotangent square theta. Okay. And and there any other ways, you know. So if I give you a problem like that, how to, this is from last section, right? How to evaluate this cotangent square theta. Okay. Cotangent square theta, and then I try to recall the formulas, right? So we know that the derivative of cotangent theta is going to be right. The derivative tangent theta is going to be 1 over cosine square theta. The derivative of cotangent theta is going to be here sine square theta. Okay. Now whether it's going to be negative or positive, I think it's a negative one, right? Yeah. If you forget, it's a cosecant square theta. Okay. If you forget the sign, then just apply the quotient rule to solve the problem. Because when you differentiate, it's going to be negative sign. No, there's negative shows up, right? So it's pretty sure it's negative. Okay. This is the way you know if you yeah. So you have to recall some formulas, but then you get 1 over sine square theta. But I have a cosine square theta over sine square theta. It's not an exact match, right? And then you think about the derivative of secant theta, but then it's different, right? The derivative of secant, cosecant, or secant theta. Okay. So theta does not work. But when you see that, right, cosine square theta can be changed to 1 minus sine theta. And if you do this, then the problems become simple. Okay, it will be this part. Yeah, you do have the formula here, right? Then you can solve the problem. It's going to be negative cotangent theta plus minus theta plus constant. Right. Now, I have to go back to x because we don't like the theta, right? So I remember x equals sine theta, and theta is between pi over 2 and negative pi over 2. So I have to change back to 6. Because of this, cosine theta is going to be positive. So cosine theta is going to be 1 minus sine square theta, because theta is between negative pi over 2. So cotangent is going to be cosine over sine. Okay, so cosine theta over sine theta, right? Now I try to convert everything to sine cosine because we are familiar with formulas for sine cosine. So it's going to be negative square root of 1 minus x squared over x minus, yeah, why 1 minus x squared? Because x is sine theta, right? So sine theta replaced by x. Now what is theta? Theta, I don't have any idea. It's arc. Just solve for theta in terms of x. Okay. So this is the formula. This is the expression. It's pretty complicated. Yeah. So are we able to evaluate square, you see, we know how to evaluate tangent theta, right? Integral of tangent theta. But can we evaluate integral of tangent square theta? Using the same idea, right? Using the same idea. Yeah, this is from last section, right? Tangent square theta. The equation is here. We have a tangent. Do slightly different way. Okay, right? This is identity. Okay. We also know that. So the integral. We know that the derivative of tangent theta is going to be secant square theta. Right. Right. So if I have a secant square theta, then I can get the integral quickly. But I have a tangent square theta, then there's no bigger difference, much different, right? Just secant square theta minus 1 d theta. Okay. Then the first one is going to be tangent theta. The second one is theta plus constant. Yeah. Yeah, we can evaluate the integral of a secant square theta quickly because we have this identity. Right? So you have to change the tangent square theta to secant square theta. So our next problem is this. Okay? How to evaluate this integral? Any idea? What is the best way to do? Huh? Okay, yeah, this should be yeah. We should use that substitution. Okay, you let u to be 1 minus x squared. Okay, then du equals negative 3x dx, and that is the one we have, right? So the integral becomes a square root u, and x times dx is negative 1/2 du. Right? So that will be negative 1/2 u to the negative 1/2 du. And then the antiderivative will be n plus constant. Okay, so let's simplify it. Denominate it just negative, okay? U to the 1/2 plus constant. So that's it. So we will get, you replace it, u by 1 minus x squared, n plus constant. So this is the answer. Now, some students say, well, okay, I did not know that. I already forgot this type of general substitution. I'm in this section, right? And about trigonometric substitution. I see square root 1 minus x. So I want to try this. Right? Let's see if we can get it. Maybe it works. Right? I don't know yet, right? So the integral becomes, and if that is true, then and that is going to be cosine theta, right? And so the integral becomes cosine theta. X is sine theta, okay? And the dx is cosine theta d theta. Not too bad, okay? That's a dx. and the cosine theta cancel out. You only get sine, and then you get negative cosine theta plus c, right? And what is negative cosine theta? You already have a x equals sine theta, right? So it still works. It's 1 minus sine squared theta plus constant. And that is going to be, right? So we can solve the same problem. And that's also typical trigonometric substitution. So then the multiple substitutions you can choose sometimes, okay? So let's do the problem. I will ask you to do this problem. X over square x squared plus 4 and dx. Let's do this in class. Okay. Right, so you look at, yeah, it's similar to the above problem, right? X, so the natural substitution is just u equals x squared plus 4. So du equals 2x dx, right? So the integral becomes, and here's just half of du, right? Okay, so the entire derivative is negative, right? Du, so let me, right? So then you simplify it, and you just get u to the 1/2 plus constant, and then you replace x squared plus 4. Okay, so this is answer. Now, if you use a trigonometric substitution, does it work or not? Probably it works. Okay, x squared plus 4. What kind of substitution you can choose? Then you have to use a tangent theta. Okay, so if you use a tangent theta, it's 2 tangent theta. Okay, why? Because x squared plus 4, then it's going to be theta is between pi over 2, right? And negative pi over 2. So that is going to be give you 4 tangent square theta plus 1. So that will be 2 and the square of secant square theta, right? And that's going to be 2 secant theta. Not too bad. Okay, but I also have to look at the derivative of tangent theta with respect to theta. That will be secant square theta. Okay, d theta. Yeah. So that is yeah, this is what we know, right? So derivative of tangent theta is going to be secant square theta. Okay. So put everything into the integral. Right? X is going to be 2 tangent theta And the denominator is 2 secant theta. And here dx it becomes 2 secant square theta d theta. Okay, let's see if we are able to simplify. 2 cancel it out. I only have 1 2 left, right? So now you have a secant theta canceled out. Okay. Tangent theta times secant theta, do you still remember, right? Derivative of secant theta, right? Constant. Okay. So yeah. So 2 secant theta. What's the relationship between this? It's here. We already did that, right? 2 secant theta is the square root of x squared plus. Okay, so you get the same answer. A little bit more complicated maybe. If you are not familiar with secant theta, tangent theta, then this is a problem. Yeah. Okay. So it still works. You get same result. Then yeah, this is in the denominator, right? X over x times square root x squared plus 4. Okay. How about, I'm not going to put x on the top. Okay. So you get dx. Yeah, I change it, just make it easier, just x squared plus 4. So for this particular problem, I cannot use a traditional substitution. Yeah. If you do, and you will see what you get. Okay, u equals x squared plus 1. I'm not sure we're going to simplify. Okay, so that is. Okay, so du equals 2x dx. Okay, the integral becomes, let's try traditions. So x square u dx is going to be half of x du, right? So you have x squared here. That's not too bad, x squared. Then you will get x squared. What is x squared? Replace x squared, it's going to be u minus 1. But they're all in the denominator. Okay? They're all in the denominator. It's harder to deal with that. Then you say, okay, I don't like the square x, square u. Can I use, get rid of the radical, right? Because the radical is still there. So you can let the v to be square u. Let's try this again. Okay. Maybe it works. Like just driving around in the city and finally get out. That takes more turns, not the shortcut. If it was without GPS, right? Yeah, you should have a GPS for this math problem. GPS tell you what is the best way to next step. Okay, the first time I used a GPS is 2007. I remember. I was amazing. Oh, great! You know, you don't even look at the map. But don't rely on the GPS. Okay, you have to print out the map if you go some strange place. It's possible your cell phone does not work and no signals. That happens in San Francisco last summer when I go down from the hill in the night, midnight. Okay, there's no signal. I was amazing. How come San Francisco has no signal? I have no GPS. I just couldn't find a way out of the mountain. Yeah, so I'm surprised. All right, so dV equals, I'm familiar with that. That's great. So I'm going to get rid of that, maybe, right? So this is a part, right? Becomes 2 dV. Great. So the integral is 1/2, and u is going to be v squared. Okay. And d over square d is d2 dv. Wonderful. Okay, so it's canceled out. You get v squared minus 1 dv. Now what? Okay, this one actually is either you can do a direct, continue work on that, or you can find the formula in the book. Okay, this is about like a hyperbolic universe of hyperbolic. You know, that's what I did in the last class. Okay, you can, yeah, give you, either you can use a natural log. Okay, yeah, if you don't want to use a formula, yeah, here's this. Page 488. Okay, let's go to page 488. Okay, on the page 488, you are given, okay, this can be negative, right? 1 minus v squared dv. It's negative. It is going to be the inverse of a hyperbolic tangent. But that one is also can be written in another form. Natural log of 1 plus v, 1 minus v. Okay, and that's it. So are we able to go back to, we already evaluated the integral, right? I have to change it to the v, to the square root u. V is going to be square root u. Okay, and what is u? U is x squared plus 1. Good. Right? That's it, right? And actually, v here is, be careful about the sign even. I think our v probably is going to be greater than 1. So now what? We have to put the absolute value symbol there. Okay. So this formula is true for v is for v less than equal to 1. Okay. So we have to be careful about the sign, because when you look at the denominator, clearly it's going to be negative. Okay. So this is going to be the absolute value. Okay. So this is the answer. Finally, it came out, right? Get the answer. You know, you use 2 substitutions. The first one is very natural. Then the second one, then third one, right? And then second. You still can modify this expression, okay? You still can modify this, rationalize the denominator, and blah, blah, blah. So you can modify this answer. Now, since our problem is in the yeah, this is x, right? So we may try to use substitutions. Trigonometric substitution. Maybe it works. Okay, it's different from the problem from the book. Okay, so you can try another one. It's going to be tangent theta. Okay, if you use tangent theta, 1 plus x squared is going to be tangent square theta, which is 1 plus tangent square, which is secant square theta. Okay, and also I needed to know dx is going to be, right? So I put everything into the integral. I will get tangent theta, and this is going to be square root x squared plus 1. So it's a secant theta, Then I also have a secant square theta and d theta. Right? Right. So now you cancel that, right? So what do you get? You get integral of secant theta and over tan theta d theta. Are we able to evaluate this integral? Okay. Maybe, maybe not, right? We already get answer from above. So we can try this, okay? Secant theta is 1 over cosine theta, okay? 1 over cosine theta, right? And the tan theta in the denominator become cotangent theta is cosine theta over sine theta. Okay, right? So, okay, great. I cancel cosine theta. So what you get is integral of 1 over sine theta. Okay, 1 over sine theta. How do you evaluate 1 over sine theta? Well, there's a formula, right? It's a secant. It's a cosecant. It's cosecant theta. How do you get a cosecant theta? Right? Okay. Yeah, let's go back to the last section. So last section, integral cosecant. I have a formula there. Now there's a secant x. Cosecant is not mentioned that, but it's very similar. Okay, idea. Cosecant. Guys, this is this cosecant theta. It's very similar to. So we don't have a formula, right? I only have the integral of secant theta. Okay, if not, then we have to use a substitution. You multiply this by that. Okay, you multiply numerator by sine theta. Yeah, you can find the formula in the back side of the book. Okay, this is the integral because this is a typical example, right? This is, how do we get the formula? I'm going to show it to you. In the back side of the book, integral of cosecant. Do we have an integral cosecant theta? No, they're not going to put it there. That's all cosecant theta, yes. Okay, so let me use the formula first. Then I try to help you to solve it without formula. Okay, so you get this natural substitution, trigonometric substitution. You end up with integral of cosecant theta, right? Yeah, integral of cosecant theta, and then you look at the book, and there is a formula there. It's going to be h log cosecant theta minus cotangent theta and plus constant. Okay, so suppose you get this. How do you get? How do you express in terms of theta? In terms of x? Okay, tangent theta is going to be x, so cotangent theta is going to be 1 over x. That's easy. Okay, right? But I know that 1 plus cotangent theta is going to be square is going to be cosecant square theta. Okay, so that means 1 plus 1 over x squared, and right. So cosecant theta is going to be positive now, right? Because theta is between pi over 2. So cosecant theta is going to be careful. It's going to be not necessarily positive, plus minus. But it has the same sign as x. So actually it's going to be x over 1 plus x squared. Otherwise you get like a at the very beginning it's plus or minus absolute value, right? But I know that sine theta has the same sign as x, so that's why I get yeah, this is a little bit tricky. So you put everything into the formula. So you get the integral to the h log of and the plus constant. Okay, this is exactly the same one we get it in last place. Okay, so we have this. We get this. Okay, and this is going to be integral. Now compare with the one we already got. There's some difference. And why this is different from that? Well, you can modify this, rationalize the denominator. So you were able to get the same answers without any problem, okay? So you should get same answers. Then you can also increase the power of x, like it become x squared, x cubed, you know, you keep it x squared plus 1, and the idea is similar. But I just, most of the problem I showed to you here, you can use two different type of substitutions, right? Still works in many cases. All right, so our next problem I want to discuss is the integral of dx and square root of x squared. X squared minus 1 in dx, okay? I'm going to begin with the first one, just the square root, the numerator. Then we do the next one, okay? So when you see an integral like that, how do you do that? You can use the usual substitution, but that does not work. Okay, x squared, let x squared to be, yeah, it's not working. So the substitution you can try is going to be secant theta. Okay, so because later on we're going to find the inverse of that, right? So theta here should be in the domain for the inverse function. Okay, so it's pi over 2, or theta is greater than or equal to pi less than 3 pi over 2. Okay, then you can find the inverse. Right. So let's look at this integral becomes. I know secant square theta minus secant square theta minus 1 is going to be tangent square theta, right? Also want to know the derivative of secant theta is going to be tangent theta, secant theta. Right. Yes. All right. So the integral becomes square root of just tangent theta, right? And the dx is going to be tangent theta times secant theta d theta. Can we evaluate this integral? Okay, we can you know, if you change it everything to sine cosine, you will get sine square theta and the cosine cube theta and d theta. So suppose you're given integral of that, right? How do you solve the problem? Okay, tangent theta square. Any idea? Maybe it's not working. Yes.
This one should be times square theta.
Times square. Hold on. Huh? Is it square or x square minus 1? Right?
Yeah.
So that will be secant square.
So again, the last line.
The last one here?
Yeah, should be times square. No, yeah. One more. Should be times square theta. Times tan theta times secant theta.
Times square theta.
There's no square theta. First time.
No, because it's radicals. It's the square root of. This is going to be square root of that. That's why it's tangent theta only. And the derivative of secant theta is going to be tangent theta times secant theta. So that's why you only have a tangent square theta. Okay. Okay. Now this, of course, you can change it to, you see, tangent square theta is secant square theta minus 1. So it'll be secant cube. Okay, this can be also changed to secant square theta minus 1. That's the only thing you can, that's the only way you can change, right? And then you get secant cube theta minus secant theta. Okay, now we do have it is going to be it can be evaluated. It's pretty complicated. Okay, so the idea is we don't have a formula there. So the idea is you already know how to do that. This is already given. Okay, so the question is how to evaluate this, and you apply the same trick. Okay, the theta. So what you do is you multiply the numerator denominator by cosine theta. Okay, then you let u to be sine theta. Okay, so the numerator becomes du. The denominator is, because cosine to 4 theta is going to be 1 minus sine square theta squared. So you end up with this. And this is a very complicated term. Okay, so we are going to study that later, how to evaluate this integral. Okay, and how to evaluate integral, it becomes like 1 minus u square 1 plus u square, and this is a polynomial. It's an irrational function. That will be the topic of next week, next class. You can, we can evaluate this integral later. Okay, I should say we can evaluate this integral later. Okay? So not every problems you can easily yeah, you can easily get the integrals. Okay. So I did not know at the very beginning. I thought that this is simple. It's not in the denominator, so I can use substitution. Eventually, I can evaluate. But you end up with secant cube theta, right? I don't think there's a simple way to get it. And if you secant cube theta, you have to use the same trick. You end up with a function like that. Okay. And now, the last few minutes, we're going to look at, I'm going to put in the denominator what about. Okay. If I put into the denominator, right, supposed to be more complicated. Right. So we do the same. Okay. Use a substitution. Okay. Then x squared minus 1, it's going to be tangent theta. Okay. So the integral becomes tangent theta. d theta is going to be tangent theta secant theta d theta. Okay. So dx is going to be tangent theta secant theta d theta. And then tangent theta is now going to be squared, canceled out. Right? That's easy problem. Okay. It's going to be the integral of secant theta d theta. Now, if you can find a formula for from the book, then this is the integral of secant theta plus tangent theta, okay, plus constant. Okay, why this is true? Okay, they already get, if you memorize some formulas like integral of secant theta, integral cosecant theta, then you can write an answer. Okay, then secant theta is x, but tangent theta is going to be what? It's going to be square root of x squared minus 1. So the answer will be x plus square root of x minus 1 plus constant. Okay? Yeah, so this goes to here, that goes to here. Okay. And where's this formula from, right? It's given, I just know that happened. Suppose you don't know this formula, okay? The standard trick here is trying to evaluate, right? So I did that. I use a substitution. I multiply the numerator denominator by cosine theta. Then I use a substitution, another substitution. I let u to be sine theta. So I get 1 minus sine square theta d cosine theta d theta, right? That's a standard technique. So I get du is 1 minus u squared. And at this point, if you still don't know the formulas, then you have to continue. Okay? If you already know the formulas, this is going to be inverse of hyperbolic tangent. Okay? So there is a formula. Yes. So this is in the book, right? Page 488. 400, yeah, page 488, and that is going to be okay. And by another formula then this is a page 487, right? This is just half of h log. Now be careful about the u. Use less than 1 or not. Yeah, use the sine theta. That's why it's okay. It's 1 plus a u and 1 minus u. Okay, and here it's true for u less than 1, but I will use sine theta. Okay, so I don't have any problem with this. Okay, but yeah, this is going to be half of natural log. It's 1 plus sine theta, 1 minus sine theta plus cos. Okay, but still, yeah, we already use the substitutions. X equals secant theta, right? So you have to change it to x. You have to change it to the x. So x equals secant theta. Yeah. X equals secant theta. So how can I change it to x? Well, secant theta is 1 of x. In other words, cosine theta equals 1 of x. Right? And so 1 of this sine, right? We don't like the sine. So sine theta is going to be square root of 1 minus x squared, right? And this should be equal to x squared over 1 minus divided by x. Okay, be careful about the sign. Sine theta could be negative, so x also could be negative. Okay, then you put into the formula here, it is going to be 1 plus and 1 minus. Okay, then you simplify it, you get x minus and x plus. This is yeah, this is a version slightly different from the one we obtained using the formula. Here is just simple formula without 1/2 in front of the natural log. Okay, that is the reason because you multiply the numerator denominator by its conjugate. Okay, then the numerator is square, becomes square. Then you will see that the denominator is going to be 1 because x squared minus x squared minus 1 is just only 1. So you get this. Then the 2 can be canceled out. Take it down here. So you get natural log of x plus x squared minus 1. Okay. So this is this is the way we solve the problem. So there do have multiple ways to solve the problem, but if you can memorize some integrals like integral secant theta, integrals cosecant theta, then that saves you time to evaluate them. Okay, you're not given the formulas during the test and quizzes. The very, very last point I want to point out is sometimes you are not given the standard form. You are given the integrals such as like that, 3 minus 2x minus x squared dx. So it does not look like any form you are familiar with. Okay, so you have to do the completing the square. Okay, you have to modify it. It's going to be x squared minus plus 2x. So this will be x squared plus 2x plus 1 minus 1. Then this becomes a square. So finally, I get 3 minus, so it's 4 minus x plus 1 squared. Okay. So the above integral is going to be integral of x over 4 minus x plus 1 square and dx. Okay. Then this looks like a pretty standard formula. So you let u to be x plus 1. Then this integral of u is going to be u minus x is going to be u minus 1 and square root of 4 minus u square and du. Okay. Then you still have to separate to two integrals. And then, yeah, when you look at this, right? So you can deal with the first one without any problem, then deal with the second one use a trigonometric substitution. Yeah. But you can also do together. Okay, you can also try to, the standard substitution is you can let u to be 2 sine theta, right? Du equals 2 cosine theta d theta. Okay. So now the integral, after you plug them into the integral, is going to be 2 sine theta minus 1. Du is 2 cosine theta d theta. And denominator is 4 minus 4u square. 4 minus u square is going to be actually 2 cosine theta. Okay. Yeah. 4 minus u square is going to be 4 cosine square theta. Okay, so you take it out, and this two cancel out, and you get pretty simple integral. And the antiderivative of this is going to be negative cosine theta minus theta plus c. So what is my sine theta? Theta is going to be, sine theta is going to be half of u. Cosine theta will be square root of 1 minus sine square. Okay. And the minus theta is going to be arctangent u of 2. Okay, so what is u? U is x plus 1. So there are two substitutions involved. Okay, so that's it. Then you can simplify a little bit if you want. And this is answer. Okay. Problems getting more and more complicated. There's so many substitutions involved. Two substitutions. Finally, we evaluate the integral.